Hey everybody, I'm Mandy. Hey everyone, I'm Mandy.
I'm Sly.
And this is our project for the DIY water sensor monitoring for engaged communities in Madagascar. So what's happening in Madagascar? So there's Lake Palliser, which is right there on the map, and it's typically used for recreation and for rice farming communities. But Madagascar has a lot of land formations called lavicas, which are pictures here, and they create a lot of erosive forces, which transport sediment downhill and into the waterways, which lowers the quality of water for these communities. So Conservation International is a company that implements a restoration project to help mitigate this issue by planting vegetation, mainly trees in the watershed to stabilize the sediment. And this project was implemented with the focus of community engagement. So them being involved with the establishment and implementation of this project.
So how the IIC is helping is we're the gap in knowledge is how the deforestation is contributing or not contributing to erosion. Ideally, with more trees, there will be less erosion, water quality will be better. But to actually test this, we have to monitor. And we're using turbidity, which is a measure of basically how see-through the water is. The problem is that commercial turbidity monitors are very expensive and inaccessible in the area. So the IIC in past years has helped design these DIY low-cost water sensors, which are there, which cost about $30 each to make, as opposed to $2. And the idea is that these will be these are accessible to communities in Madagascar, so they can monitor. And what we're helping with is where to apply the sensors and how to analyze them. So to do this, we have 3 objectives. One was to identify priority locations for sensor deployment in the watershed. There's a map of the watershed there. Develop a plan for community engagement and involvement, and to generally improve the deployment process of the sensors.
This is a message from Michael, who's conservation partner with us, and he works with Conservation International, and he's having Madagascar and deploying the sensor.
Conservation work is charged across Madagascar, land use the marks of nature to be, where climate change intensifies droughts and heavy rains, and human pressures like charcoal production and transport farmings will be eaten away at the forests. Conservation International works closely with local communities to restore forests, stabilize eroding sites, and protect the watershed that sustain life. However, to fully understand the impact of these restoration efforts on land and water, and to encourage local communities actively protect rather than degrade the natural resources, we need a reliable, continuous, and easy to collect data. To monitor these changes, the team developed low-cost do-it-yourself water system. With a working one, collecting baseline data is the first step before doing monitoring. So, field agent from Madagascar, local resident from Tron, install and maintain the sensor and to trade data. Ensuring that this data collection continues safely, sustainably, and locally monitored. Meanwhile, understanding and analyzing data is key. Side notes for William and Mary have joined this exciting project to explore methods for data analysis and practical application for the results. conservation work is charged across?
So our methods, so I used ArcGIS to take multiple environmental, I've used ArcGIS to take multiple environmental variables and assess them and how they impact turbidity, such as forest cover, proximity to lava, which is, that picture on the far left, sorry, and erosion risk factors, etc. And we also made poster materials to engage the community of why and how to be involved with our project. And then lastly, in this summer in Williamsburg, we took 2 sensors and deployed them in 3 different streams around Williamsburg. That kind of mimicked the topography of Madagascar to test the turbidity levels and just monitor observation of turbidity throughout the summer according to different weather events.
So we made some posters for the community in Madagascar. There's some examples of what we did. Some are more meant to explain the importance of turbidity monitoring and why the reforestation will help water quality. And others are, the one on the right, are more meant to convey how to do the monitor. We collected turbidity locally in 3 streams around Williamsburg. These 2 sensors at each one, going for about a week each time. We also took samples to compare to commercial turbidity monitor to track the accuracy of the DIY sensor. And we collected weather data to see how weather is affecting the turbidity. And made a GIS map of the local.
So here is a sensor suitability map that I made for the Williamsburg watershed. The 3 green points are the 3 different locations where we tested the turbidity. And I used a similar approach to Lake Ultra, but I measured the impacts of elevation, forest cover, and proximity to waterways.
So here's a sample map or graph of the weather and the turbidity correlate. We collected this sort of data for all the sites which we did. Michael has been moving on to collecting baseline data in Madagascar, and over the winter and the rainy season, they'll start collecting more data about how this is sort of baseline data and where continue collecting data as they're collected.
So these are the results for the sensor suitability map. So one on the left is a sediment deposit crystalline, and the darker shades of brown are where we would find higher turbidity levels and more sediment. And then the map on the right is a sensor suitability map. So the lighter colors, those are the areas that you would want to place the sensor and they're most suitable for that. And these are all calculated according to factors such as elevation, erosion radius, proximity to lava flows, waterways, etc. And this is another map of the watershed. So in order to make change in Lake Ultra, we need to make change in the smaller 3 feet into it. So these are 8 different microsheds which within the bigger watershed to monitor these smaller streams and assess changes in. So our main key findings is that the southeastern region of the Lake Ultra watershed is the most suitable for sensor placement, and we want to test specifically in small upstream rivers. And to use these maps that I just showed you is honestly respective to the goals of the user, but to measure in and out of restoration sites or from higher level sediment risk.
Another part of our project was improving the sensor deployment process. So we were getting out there, figuring out the challenges and ways to mitigate them. So one of the key challenges we had was water getting in the turbidity movement. So we added a towel to improve that. The battery life is also a big challenge. So we're going for shorter times, so the battery doesn't go through. Another challenge is the calibration. The through the process to make sure that the monitor is accurate. So that's the area where it's not completed. As far as the weather and the data we collected, we found that the weather did have some effect on turbidity, but the site itself. So the implications for this, we're hoping that this will lead to accessible water monitoring. That will be simple to use and accessible to people. And we're hoping that this can make monitoring more accessible to different communities, so communities with self-same purpose.
Another implication is the easy community-based monitoring with our building process of why and how we deploy these sensors. And what this project means more broadly is that not every environment is uniform, so for the factors and variables that are used to assess those, some are very different because the environments and variables are very different respects to each other. So we just want to say thank you to all of our partners, specifically with us, Kidwell, Michael, Jimmy, Myra, and Mandy. This process.
Good morning, good afternoon, everyone. It's a pleasure for me to be virtually here today to share a brief overview of the Priceless Climate Coalition Project in Madagascar, mostly known as the Peace Project, and also to highlight the vital role of student-led research and advancement of conservation goals. At the heart of this initiative is Lake Alauta. It's Madagascar's largest lake and also a Ramsar site of international importance. This region is not only the island's main vast-growing area and resource for freshwater fish, but also a landscape deeply intertwined with local culture and livelihoods. Unfortunately, it's also one of the most vulnerable ecosystems of acidification due to deforestation and land degradation. The lake has shrunk to just 21% size. With the PPC project, our goal is to restore the 5,000 hectares of the lake for cost-effective network like Red Sea and assisted network information. But restoration alone isn't enough. We must also monitor its effectiveness, especially on freshwater system. And this is where our collaboration with students becomes so powerful. By developing and deploying low-cost, locally assembled turbine sensor, students from William and Mary University of Baltimore and the communities working with us to find changes in water quality in community. Their research is technically impressive. It all started with the first homemade water sensor by the first control customer self-doing. This was the 63 in Madagascar, in the village of 3. It was then followed by the improvement of this device by another protocol for students, but this time with a direct cost for children in very fun, especially in Madagascar, to spend 2 weeks in this purpose. Currently, we are lucky to have the contribution of Mandy and Side who help us choose the best solution. Locate in the person who wants this. Mandy and Side, thank you for helping us collect the best data and providing us the best locations to deploy the sensor based on the research that you have conducted, looking at all the factors that might influence water quality. This partnership between CI and William Mary University exemplifies how science, community, and education can come together to create a lasting impact by empowering the next generation of conservation leaders. We're not just restoring landscapes,